Hello students, how are you? I hope you all are fine and fit. So today I am going to discuss the topic of physics, that is magnetism. So what is the magnetism? Magnetism is phenomena of attracting. As you know that if we keep iron, nickel, steel, cobalt near the magnet and they get attracted towards the magnet, and that phenomena is called magnetism. So magnetism is a phenomena of attracting iron, nickel, steel, cobalt towards ore of the iron is called magnetism. And there is a natural occurring magnet that is called natural occurring magnet, that is iron ore, that is Fe3O4. It is called magnetite. It is called magnetite. But there are some artificial magnets also, and the magnet which are made up of iron and steel, these are called artificial magnet. The magnet which are obtained from this iron, nickel, steel, that are called the artificial magnets. And there is natural occurring magnet which is so artificial magnets are there. Artificial magnets are there and which are obtained from the natural occurring magnet, keeping iron, nickel, steel near to the magnets. And these magnets are in the shape rectangular, circular or horseshoe magnet. So these are the artificial magnet. Now I am telling the properties of the magnet. So first property is that every magnet attracts iron, nickel, steel, cobalt. So it means magnet has attractive property. Second is that if we suspend a magnet through a thread, then it points towards the geographic north and geographic south, and the pole, the end of the magnet which point towards the geographic north is called north pole, and which point toward geographic south is called south pole. It means that every magnet has two poles that are north and south, but monopole never exists. Monopole never exists in nature. Means if we break a magnet into smaller pieces, then it again become a new magnet. that will also have two poles that are north and south pole. Okay, so it means every magnet has two poles, that is north pole and south pole. Next property is that like poles repel each other and unlike poles attract each other. Means if we suspend two magnets by thread and if we bring closer to each other, then we can see like poles. It means if north and north pole come near to each other, then both the magnets will repel each other, and same for south. But if south and north pole comes nearer to each other, then they attract each other. It means like poles repel each other and unlike poles attract each other. Next property is that there is force of attraction or repulsion as on the basis of the property repulsion and attraction. So that force is directly proportional to, it may be attractive as well as repulsive. It is directly proportional to product of the pole strength and inversely proportional to square of the distance r between the poles. So now I am combining these two equations. So F is directly proportional to m1 m2 by r square, or F is equal to mu naught by 4 pi into m1 m2 by r square. So this is the formula for the force in magnetism, and the value of K in SI is mu naught by 4 pi, but in CGS it is 1. Okay, so value of K is mu naught by 4 pi in SI system, but in CGS value of K is 1. So force of attraction or repulsion between the poles of the magnet is equal to mu naught by 4 pi into m1 m2 by r square, and this mu naught by 4 pi is equal to 10 raised to power minus 7 Weber per ampere per meter. Clear? Now if we want to define pole strength equal to 1, then if m1 is equal to m2 is equal to m and r is equal to 1 meter and force between the pole is 10 raised to power minus 7 Newton, then force is 10 raised to power minus 7, mu naught by 4 pi is also 10 raised to power minus 7, m1 and m2 both are equal, it means m into m square by r1. So by this m will become equal to, or m square is 1 you can say, and then m becomes plus minus 1. It means now pole strength will be 1 ampere meter. It is 1 ampere meter. So now I am defining the pole strength. How? That two poles of equal strength separated by distance 1 meter. If they apply force of attraction or repulsion of 10 raised to power minus 7 Newton on each other, then pole strength will be 1 ampere meter. Okay, if two equal poles of equal pole strength separated by 1 meter exert force of attraction or repulsion of 10 raised to power minus 7 Newton on each other. Then pole strength will be 1 ampere meter. Now next property is that if a magnet is placed near the magnetic material, if a magnet or magnetic material, you can say, if magnetic material is placed near the magnet, then it attains magnetism. Magnetic material is placed near the magnet, it attains magnetism. Like iron, nickel, etc. They also attain magnetism. Or for example, if we keep some nails near a magnet, if we keep some nails near the magnet, then after some time they also behave as a magnet. It means they have attained the phenomena magnetism. Or if we keep some iron fillings near the magnet, then they also attain the phenomena of magnetism. And each magnet has two poles, that is north and south pole. But monopoles never exist in nature. Means single pole never exists. Charges single can exist, but poles can never exist single. Okay. So, and if we break a magnet into smaller pieces, then it again becomes a new magnet having two poles, north pole and south pole. Now, I am telling about the magnetic field lines. Magnetic field lines. So what are the magnetic field lines? These are the path. These are the imaginary curve. It is an imaginary curve. Or you can say it is a path along which north pole of a magnet moves. It is a path along which north pole of magnet move. North pole of a magnet moves. How? If we take a magnet and we keep here a compass needle, then you can see that this compass needle will turn about, and then we will mark the points, and those, if we join those points, then that will be a curve, and though that curve is called magnetic field lines. Or for example, if you keep some iron fillings near a magnet, then they also arrange in a beautiful pattern. That pattern is called magnetic field lines. So this is the path along which north pole of a magnet moves. And one more thing is that tangent to these field lines, tangent to field lines gives direction of magnetic field. So if we want to know the direction of magnetic field, then by drawing the tangent we may find the direction of magnetic field.